Welcome to Chapter 7, Section 2, Electrolytes and Non-Electrolytes. Solutes can be classified by their ability to conduct an electrical current. So when solutes called electrolytes are dissolved in water, they can separate into ions, forming solutions that are able to conduct electricity. If we have a strong electrolyte, they will produce lots of ions and conduct an electrical current. If we have a weak electrolyte, such as HF, you see down here, each of these are labeled. We'll come back and discuss these. They will produce a few ions and produce an electric current, just not as strong of a current as a strong electrolyte. Non-electrolytes do not produce ions, therefore they are not going to dissociate in water and there's not going to be an electric current. To test the solution, you can use an apparatus that consists of a battery and a pair of electrodes connected by wires to a light bulb. Okay, and the light bulb glows when electricity can flow. And if we look at NaCl, this is a strong electrolyte, we get this bright light in our bulb. If we have a weak electrolyte, such as HF, it has a weak light, so it's not near as bright as our strong electrolyte because it produces fewer ions. If we have a non-electrolyte, then we get no light at all. There's no electric current. Strong electrolytes are solutes that dissociate in water completely. So they produce a positive and a negative ion. They conduct the electric current in water, and this is the equation that we use to show strong electrolytes. So NaCl in water, we get 100%. So this arrow here is saying that we are producing 100% Na plus Cl minus. Okay, remember where these charges come from. Sodium, if it loses one electron, to be like the nearest noble gas, it's in group 1, so it has a +1 charge. Okay, the chloride has a -1 charge. It wants to gain 1 electron to be like the nearest noble gas. Don't forget where these charges come from. Okay, so if we were to write out the equation for a strong electrolyte in water, okay, the key here is that we have 100% dissociation into its constituent ions. So if we were to, we've got an A, B, and C answer here, but we're going to go through and work the problem together. Okay, so if we have, okay, well it's here for us, so let me, okay. Alright, so calcium and chloride. Okay, we've got calcium chloride, and we want to write out what it's going to dissociate into. Okay, if we know it's a strong electrolyte, then we know we're going to produce calcium. We're going to talk about the charge here in a second. And we're going to produce chloride. Okay, but now we have to look at charges, and we have to be sure our reaction's balanced. Okay, and so how we would do this is we know that calcium is in group 2, so it's going to form a +2 charge. Okay, calcium's in group 2, forms a 2+ charge, and we know that our chlorine as an ion, it has a -1 charge. Okay. So the only thing we have to worry about here now, we've got our charges there, but we do not have our stoichiometry correct. We don't have the same number of atoms on each side. We've got a 1 calcium, and we've only got 1 chlorine, whereas we need 2. Okay, so we're going to need 2 chlorines there. Okay, so sorry, that plus sign doesn't look too good there. Okay, so that's a plus. So if we look down at our answers here, it would be C. So an aqueous solution, so in water, calcium will dissociate into its constituent ion of Ca2+, and chloride into 2 Cl minus, because you have 2 of them on the left side of the equation. Okay, If you want to stop and work 2 by yourself, you're welcome to, and then turn the video back on. We're going to go ahead and go through it. So a strong electrolyte completely, so we have 100% dissociation. Okay. And what we're going to do now is we're going to look at, if it dissociates, we know it automatically is going to knock out B because we're dissociating it into its constituent ions. Okay, our potassium, we've got 3 of those, and it is in group 1. We're going to get 3 of our potassium plus 1 ions. And we want to look back at our polyatomic ion list. We have phosphate, so this is a polyatomic ion with a charge of 3-. That's where that comes from. So you do not break it into 2 separate nonmetals. You have to recognize that it is a polyatomic ion, and yes, you're given this list, you'll have to memorize, but you still have to be able to recognize it. Weak electrolytes dissociate only slightly in water. So they will produce, so we still see that our light bulb is giving off a little bit of light here, okay, but not near as much as our strong electrolyte. And they only will dissociate slightly. And so what happens is you actually get, this is called an equilibrium arrow. Okay, whereas previously we had a single arrow, 100% dissociation. For a weak electrolyte, we don't have 100% dissociation. We've got an equilibrium arrow, meaning that we're forming ions, but we're also reforming back our starting material, or our reactants. So it's almost like you have a forward reaction going on, but then you also have the reverse reaction going on, meaning that it cannot 100% dissociate into the ion. So only a few ions are present in the solution, because the other, these are recombining, so they're recombining, so H plus F minus recombines to form HF. This is what this is showing here. Okay, and so there's a list of weak electrolytes that we're going to get to here in a minute, but the main thing is to recognize the equation. So if you see the double arrows, so you see the equilibrium arrows, the forward and reverse reaction arrows, this means a weak electrolyte. If you see the single arrow, or if we look back here, you see the single arrow, this means 100% dissociation into the constituent ions, and this means strong electrolyte. Equilibrium arrows mean weak electrolytes, and if we have no ions present, these molecules basically dissolve as molecules in water, and they do not produce ions in water, and they will not conduct an electric current. So if we look at the table, you will want to be very familiar with this table, but you will not have to memorize it. Okay, you'll either be given the reaction where you can recognize if it's a strong electrolyte or weak electrolyte based upon the reaction arrow and if ions are present. You can recognize the non-electrolyte if given a reaction based upon, you have the same thing on both sides. So basically you have sucrose on both sides of the equation and you have no ions. So that's your key that it is a non-electrolyte. But I will either give you the table or I will tell you this is a strong electrolyte, and you may have to answer questions about it, like does it conduct electricity and things of that nature. But it is good to go ahead and get familiar with these, and you can kind of see some trends in the examples. This concludes the video on electrolytes.